In number 13, I have negative 3/4 pi over 9. Now we don't really deal with ninths of pi. So I'm not really sure exactly where this is. So I'm actually going to undo it a couple of times here so I have a better idea of what I'm dealing with. Although I could do that, but I could also think of it this way. Well, that's how I did it on the key. Maybe that's how I should do it. Yeah, let me do that. I'll do it how I did it on the key. So I can see here that I've gone one time around and I'm about to go 2 times. I'm just 2 times shy of going around. Well, 2 times around is going to be 4 pi. Okay? And 4, I need 4, the equivalent to 4 over 1 with 9 in the denominator. Well, that's going to be 36, right? So, right here, this right here is going to, I need this much more to give me 36 pi over 9. Now this is negative, and so I am going to do negative 34 pi over 9 plus 36 pi over 9, and that's going to give me what's left right here. So that gives me 2 pi over 9, and that is what is left. So I have 2 pi around, and I subtracted this part, and that gave me what is left. And again, it's positive because reference angles are positive. Okay, and finally over here, I can think about it this way. 200 degrees is the same thing as 180 plus 20. Okay, so 180, and then I have 20 more. That's my reference angle. Okay, and it looks like I have to come back to get it, which I kind of do. Again, there's no direction, so it's not negative, it's always positive. All right. Convert each radian measure into degrees, and convert each degree measure into radians. All right, so for number 15, it's in radians. I want it in degrees. So since I want it in degrees, degrees is going to go on top because I want the pi's to cancel. Okay, 180 and pi are the same thing. So this is the same thing as multiplying it by 1. So the pi's cancel. Negative 180 degrees over 6 is the same thing as negative 30 degrees. Okay, over here, again, I'm going to multiply this by 180 degrees over pi. The pi's cancel, and when I put this in my calculator, I end up with 660 degrees. Okay, this time we're going to flip it. I have it in degrees, I want it in radians. So radians on top, degrees on the bottom. You're going to put in 225 divided by 180 in your calculator, and when I do that, I get 1.25. Okay, now I know that's 1 1/4, but if you don't know that, then you're going to hit math. That fraction button comes up. You're going to hit enter, enter, and it gives you this fraction simplified, totally reduced. Okay, so this is 5 pi over 4. Okay, come over here, do the same thing. This is pi over 180 degrees. Okay, 285 divided by 180 is 1.583 repeated. I hit math, enter, enter, and this is going to be negative 19 pi over 12. Remember, don't include the pi. Just do 285 divided by 180 to figure out the fraction, and then put the pi on it. Okay. Find the length of each arc. You will need the formula S equals the radius times theta, and theta is in radians. That will be, you won't need to memorize that, that'll be on the test. Oh, I better hang on to that. Okay, so this is in degrees, so I need to change that. So 60 degrees times pi over 180 gives me pi over 3. All right, and then I have arc length. Okay, that's this piece right here. That is like a fence. Okay, it's not the area of the whole thing. Okay, this is my radius, 8, times pi over 3, and that gives me 8 pi over 3. And that's how I would like it on the test, too, is in this form. And that would be meters. If you don't put meters there, I'm not going to freak out or anything. This one's nice because it's already in radians. So S equals my radius times theta. So I have 35 pi over 3 kilometers. That's it. Very, very quick. All right. All right, we need to do 21. We'll start with 21 on the next video.